المعرفة International Private School Thermal Physics IGCSE 0625 Learning Objectives 231 Conduction Core Describe experiments to demonstrate the properties of good and bad thermal conductors. 232 Convection Core Recognize convection as an important method of thermal transfer in fluids. Relate convection and fluids to density changes. 234 Consequences of energy transfer. Core Identify and explain some of the everyday applications and consequences of conduction and convection. Supplement Give a simple molecular account of the conduction in solids, including lattice, vibration, and transfer by electrons. Let us firstly to revise the definition of temperature, heat, and thermal energy. Temperature is the average of kinetic energy of individual particles in a substance. As you see here, the cold chocolate has low temperature because it has low average of kinetic energy, while here the hot chocolate has high temperature because it has high average of kinetic energy. Second, thermal energy. Thermal energy is the total of kinetic energy and potential energy of particles or molecules or atoms of an object. Now, heat is the transfer of thermal energy from hot object into cold object, from hot resource into cold water in the container. So heat is the transfer of thermal energy from high temperature into low temperature. When the thermal energy is transferred from hot object into cold object, the particles move faster and the kinetic energy of the particles increase. Now, as you see here, we have two containers. We place a container, the red one, with 5 Celsius, low kinetic energy, and a big container, which is 70 Celsius, with high average of kinetic energy. When we place the cold one, 5 Celsius, and the hot container, which is 70 Celsius, the heat transferred from high temperature, 70 Celsius container, into cold temperature, which is 5 Celsius. After some time, the two containers, they have same average of kinetic energy, same temperature. So we name this case thermal equilibrium. The thermal energy transfer from hot object into cold object, from high temperature into low temperature, and we name this concept by heat. Heat transfer through 3 methods. Number 1, conduction. Number 2, convection. Number 3, radiation. Now conduction, thermal conduction. In thermal conduction, as you see here, we have a metal bar. If we remember the kinetic energy theory, all materials or all matter, they are made up of tiny moving particles. Now in solid, as the metal bar here, the particles, they vibrate in a fixed position. Now, if we expose the heat from this side of the metal bar, after some time, the neighbor molecules that expose directly to the resource of heat, they start to vibrate more. Then this thermal energy will be transferred from this molecule that is directly exposed to the heat to the adjacent one. Then thermal energy transferred from this adjacent one into the second one, then as well to all molecules until thermal energy reaches the cold part from this side. This is the way to transfer heat through solids. So as you see, the thermal energy transferred from one molecule into adjacent or neighbor molecule, then as well to the next one, then next, until all energy transferred through the metal bar. Now this process happens without transferring or moving of molecules, just the extra kinetic energy transferred to the second molecule, then to the third molecule. And as well, if the temperature between the two sides, difference in temperature between the two sides is more, the transfer will be more. And this arrow, the yellow one here, represents the transfer of energy from the hot side into cold side of the metal bar. After this process, the cross-sectional area of the metal bar will be more, and the length of it will be less. Now, in thermal conductor, we have thermal conductors and we have thermal insulators. We can classify materials into thermal conductors and thermal insulators. Now, in thermal conductors, all metals, they are thermal conductors. They feel cold to the touch as heat is quickly conducted away from your hand, while non-metals, they are poor conductors and bad conductors. Since when we touch them, we feel with warm, there is no any thermal energy transferred from our hands to the non-metal. We can name also poor conductors other name, which is insulators. And liquids are poor conductors. Now gases are the worst of the all of liquids and solids. Also many solids, they have tiny pockets of trapped air. The following experiment, we use a heat resource, and here we have four different metals from same size, same volume. As you see here, they are exposed to the heat with equal distances, and we fix at the edge of each one piece of Vaseline. Now we have four metals. This is brass, here we have steel, here we have copper, and here we have aluminum. This experiment is to investigate which metal is the good conductor, which metal is the bad conductor. After some while of exposing this side of the metal to the heat resource, same time interval, we observed the following. In the following table, we have the time that is taken for the Vaseline to fall down. For aluminium, it was 125 seconds. For brass, it is 189 seconds. For the copper, it is 73 seconds. For steel, it is 340 seconds. As you see, the copper has the least time to fall the Vaseline, and this is the least time. And for steel, it is the highest, 340. The meaning of this, that copper is the best conductor, it takes the least time, while the steel is the worst of the all, it takes the most of the time. So as you see, copper is the best conductor of the thermal energy, with steel is the worst one. Look at the table of the conductivity value or rate. For aluminium, it is 204. For brass, it is 109. For copper, it is 385. For steel, it is 16. So the conductivity rate for copper is the highest, and the conductivity rate for the steel is the lowest. That's why it takes longer time for steel to fall down the Vaseline piece, and less time for copper to fall down the Vaseline piece. Now look at this question. An experiment is set up to find out which metal is the best conductor of heat. Balls are stuck with the wax to the rods made from different metals as shown in the diagram X. The rods are heated at one end. Some of the balls fall off, leaving some as shown in the diagram Y. Now, which labeled metal is the best conductor? As you see, this is before heating and this is after heating. We have already 1, 2, 3, 4 balls. And at D, the 4, they still here after heating. For C, 2 falls and 2, they are still here. For B, 1 falls and 3 are still here. For A, 1 only left. So which one is the best conductor? For sure A, since 1 is left here and 3 fall down. Now, second question. A rod is made up of copper and wood joined together. After the rod is heated at the joint in the center for about a minute, where would the lowest temperature be? So as you see, this is copper metal, and here we have wood. Which point will be the lowest temperature? For sure, it will be A. So B is higher temperature than A. Wood is insulator. So for sure, the lowest temperature will be at A. Look at this experiment also. We have a tube that is filled with water. And we have gas here that is covered a piece of ice. And we expose the heat from this side. After some while, the water heated up and start to boil, while after some time the ice doesn't melt, it is still solid. Now, as you see, the conclusion and the result of this experiment, that the water is poor conductor of thermal energy. Since this one is covered with gas, the heat does not transfer to the ice since water is poor conductor. Look at this question that is related to the previous slide. An experiment is carried out as shown in the diagram. Here is same our experiment. Now the question is what? Why does the ice take a longer time to melt, even though the water at the top of the tube is boiling? A, convection never occurs in water. Ice is a poor conductor of heat. Now, the gas prevents the energy reaching the ice. Water is poor conductor of heat. So as you see, based to the experiment, water is a poor conductor to heat. So the answer is D. Look at the applications on thermal conduction. Here we have most of buildings in cold countries, they are built from wood. And as you see in this figure, wood will prevent transfer heat to outside. This will help to more insulation for heat and to keep the houses warm inside because of cold weather. Other application here, we have the double glazed windows. They are 2 sheets of glass, and in between them we have air. This will help to improve insulation and reduce conduction. Here also the other application here is cavity wall. As you see, we have 2 walls here, and in between the 2 walls we have some plastic forms or beads or mineral wool, and this will help to improve insulation and reduce conduction. Other application here in loft insulation, glass or mineral wool with air trapped between the fiber will help to improve insulation and to reduce conduction. And see this application, it is about this plastic foam lagging around the hot water storage tank. This will help to improve insulation, and it will help to not conduct the thermal energy from hot water to outside. Here are the applications. See, this is a more clear photo about the application of double glazed window where the air is trapped in between to help insulation. Now the explanation about conduction. We know that in a metal there are many tiny electrons fixed inside the atoms. Some, however, are loose and free to drift between the atoms. Now, if the metal is heated, then the free electrons start to move more quickly. This free electrons are moving randomly within the metal. They may collide with the atoms and make them vibrate more quickly. This means that the thermal energy is transferred rapidly to all parts, making metals good thermal conductors. Now, any material that conducts will have particles vibrating and pushing on neighboring particles. But in metals, this energy transfer through the movement of free electrons means that they conduct energy much more quickly. Now, in insulators, they don't have freely electrons to transfer the thermal energy. That's why they are poor conductors. Now, the summary of conduction. We said that the process of heat transfer along a body from the hot end to the cold end, from one molecule to another, without actual motion of molecules. Actual motion of molecules is the definition of conduction. Now, conduction is not possible in vacuum, as medium is not required for it. So in vacuum, we don't have medium. That's why we don't have conduction. Now, we need medium to transfer heat through conduction. That's why in vacuum, there is no conduction. Now, in solids and mercury from liquids, they are the two materials where the energy can be transferred through conduction. So mercury is a liquid, and this is exception for liquids to transfer heat through mercury by conduction. Now, we can classify matter into two types. We have good conductors and we have bad conductors. Good conductors, the substance which allows heat to pass through them faster, are called good conductors. Good conductors of heat, example metals, are good conductors. Now, the bad conductors, the substance which do not allow heat to pass through them easily, are called bad conductors of heat, such as nonmetals, glass, paper, clay, wood, and others. And as we said, mercury is exception from liquids that transfer heat through conduction, while all liquids and gases, they are poor conductors. Now, convection, the second one. In convection, we have actual movement of particles to carry thermal energy. Now, liquids and gases are poor conductors of heat, but because their particles are free to move from place to place, so they can transfer thermal energy by convection. Now, can we see convection in a liquid? See this question. Yes, we can. As you see here, we have a container of liquid, and this container of liquid exposed to a heat resource. The water above the heat resource directly will become warm. Then it will expand and raises up as its density decreases. Then after, the cooler, more dense water sinks to the bottom of the beaker. It is then heated up. Then after, it will raise up. This circulation of warm and cold water sets up a circulating stream called convection current. So as you see here again, the near layer of water will heat it up, it will expand, its density decreases, then it will raise up. This current that raised up called hot current. Now, the cold molecules will replace it. Then this is called the motion of the cold water that sinks down, called cold current. So this cold current will move down, as well the process will repeat it again to have convection currents until all of energy distributed to all containers. Now, convection and gases. As you see, this is actual example from our life. During daytime, as the sun shines, land heats up more quickly than the sea. This results in air being warmed and rising. This warmer air is replaced by cooler air coming from the sea. Now, the reverse happens during nighttime. The sea remains warmer than the land and cools down more quickly. Above the sea, the warm air rises and it is replaced by cooler air coming from the land. Now, convection in our homes. This is example from our homes. As the convector heater warmer, it is warmer, it heats air immediately above it. Then after, number 2, the warm air rises, carrying thermal energy all around the room. Then after, number 3, the air cools, so it falls toward the floor before being heated again. So as you see, number 1, where the radiator heated up the neighbor molecules of air, then as they heat it up, they expand, they become less dense, then they raise up. And number 3, the cold air replaces the hot current, then after it will heat it up and the circulation will continue to distribute the heat through the air of the room. See this application about an refrigerator. So in the refrigerator, the cool air sinks below the freezer. This sets up a circulation current of air which cools all food in the refrigerator. So cold air will go down, see these arrows, and the warm air will go up. As the warm air reaches up, it will start to cool down and its density will be more, then it will go down again. Hot current upward, down current downward. This circulation is called convection current. The summary of convection. Convection is a process of transfer of heat by the actual movement of particles of the medium. We have 3 important points. Number 1, a medium is required for the transfer of heat by convection. Number 2, liquids and gases are bad conductors of heat. They are heated mainly by the process of convection. Now in a solid, the atoms cannot move or leave their positions. So the transfer of heat in solids by conduction. Conduction is the way to transfer heat through solids and mercury, while convection is the way to transfer heat through liquids and gases. Now, the procedure of convection. By the process of convection, the transfer of heat is always vertically upward. Now, this is because the medium particles near the source of heat absorb heat from the source and start moving faster. As a result, the medium near the heat source expands and thus becomes less dense. So it raises up and medium from the surrounding and above being denser moves to take its place. Thus, a current is set up in the medium called convection current. The convection current continues to transfer heat for all medium. Now look at this question. A heater is placed in a room. Which diagram shows the movement of air as the room is heated? So as you see here, the answer is A. The hot current is moving up as it is expand and it becomes less dense, and the cold current moves down as it is more dense and the molecules are closer to each other. So B is wrong. See the motion from down to up, then C also, this is wrong, D also is wrong. So A is the right one. Second question, which line in the table is correct about conduction and convection? A, can happen in a solid for conduction for convection. B, for conduction can happen in a solid, for convection only happens in fluids. C, only happens in fluids for conduction, can happen in a solid for convection. D, only happens in fluids for conduction, only happens in fluids for convection. So the right answer is B. Conduction happens only in solids and convection happens only in fluids, liquids, and gases. Third question, density changes are responsible for which method of thermal energy transfer? A, conduction only. B, convection only. C, radiation only. D, conduction, convection, and radiation. We said that density is responsible only in the method of transferring energy through convection. So the right answer is B. As you see here, a heating, number 4 question, a heating element is positioned in a narrow sealed tube of liquid. What would be the best place to position the heating element in order to obtain the best circulation of the liquid through the tube? So as you see, here are the positions A, B, C, D. So the best circulation will be at C. The best circulation through the tube will be at C. Look at this question. The diagrams show 4 identical pieces of ice that are heated in test tubes of water. Now, in which test tube will the ice take the longest time to melt? Here is A, here is B, and B, the ice wrapped in a lead wire. Here also is C, and here is D. The answer is B. This one will take, return back to our question. So the answer, the one that will take longer time is B, since the heat resource is far away from wrapped ice. See the next one? This is the difference between C and B. In C, the heat resource is exactly under the wrapped ice, and B, it is far away. So the longest time to melt, it will be, the answer will be B, choice B. Now here the diagram shows a refrigerator. The cooling unit is placed at the top. The cooling unit cools the air near it. So the question is, what happens to the density of this air as it cools, and how does it move? Now, density of air in the first column and movement of the air in the second column. A, density decreases, will move, and the movement of the air moves down. B, density decreases and the movement stay where it is. C, density increases and movement of the air moves down. D, density increases and movement of the air stay where it is. So they are asking here about the density of this air as it cools and how does it will move. So cold air has high density, so the density of it increases. So it is either C or D. And as the density is more, so the current, cold current, will move down. So the answer will be C. This is the end of our session, the transfer of heat.